Hey everyone, my name's Lewis and welcome back to the channel. As some of you may know, I recently graduated with an astrophysics degree, and since then some of you have been asking me what I thought of the degree and what I thought of the modules and courses I took. So I thought today I'd go through all of the modules that I did throughout my degree, giving my opinions and thoughts on them. And one thing to bear in mind is that some of these courses I did remotely during COVID times, and that's going to sort of affect my opinion on some of them. But other than that, I'm going to try and keep things as honest as possible so that you can get a pretty clear and grounded view. Okay, let's start with year one. Now, year one is generally a pretty basic year across all universities. And the reason for that is it's designed to give everybody an opportunity to get on the same level of understanding with maths and with physics concepts. So we had a couple of modules that were designed to teach us the foundations of maths, and others for physics, and then others for other skills like astrophysics and programming and experimental physics. So starting with the maths modules, we had two dedicated maths modules called Maths Methods for Physicists 1 and 2. And those taught the groundwork for most of the maths that we would use throughout the whole degree. So stuff like vector calculus, which is incredibly important throughout all of the physics degree basically. We had sort of coordinate transformations, which were again really important. And then we had stuff such as matrices, which again is really important, more so for special relativity and quantum mechanics. So the maths modules give a pretty good overview of all of the maths that we would need later on in other modules in year 2 and 3. And of course the maths was developed in those modules as well, but the foundation was needed from the maths specific modules. And then we had mechanics and matter and electricity, magnetism and waves, and those were sort of the foundation of the physics concepts that we would learn. So mechanics and matter was a first semester module focusing more on stuff like macroscopic interactions with objects through forces and kinematics, whereas electricity, magnetism and waves, as you can guess, focus more on the electromagnetic spectrum and an introduction to sort of optics and light. So those are the sort of 4 foundation modules for pretty much all the concepts that were needed in the physics later on throughout the degree. But we also had modules on stuff like experimental physics. So we had 2 experimental physics modules where we was in the lab once a week for maybe 4 or 5 hours. And each week we was given a different experiment to do. And some of the experiments were pretty boring and you sort of taking down data by writing it in a book. But then we had other experiments where we was experimenting with radioactive materials and liquid nitrogen, and those were really interesting. And so it was kind of a half and half module. Some of it was really interesting, some of it was a bit more tedious and monotonous, but that is sort of the point of those modules, to give you a sort of idea of what it's like to perform an experiment for hours and hours and hours. So finally we have my 3 favourite modules from first year. So the first of these was a module called Planet Earth, which was a sort of planetary and solar physics module, a very introductory one of course, but it focused on the formation of Earth, the formation of the Moon, the formation of the solar system in general, and how the inner planets formed in different ways to the outer planets. And I sort of really got on with the module. So I really enjoyed this module, and so if you get the chance to do a module like this, I would really recommend it. So following on from this was our Introduction to Astrophysics module, which, as you can guess, was an intro to astrophysics. It taught a lot more of the maths heavy concepts in astrophysics, such as the formation of stars and stuff like the virial theorem, which is pretty important with everything to do with astrophysics. And we learned a lot about stellar physics and galaxies and the universe as a whole. So it was, again, a really introductory module, but really important in terms of laying a lot of the framework and foundation that we would need in the astro modules. And finally was a module which was completely different from the others, which is computational skills for problem solving. And as you can guess, this is a module on scientific programming and using programming and coding to solve complex problems. Now I really enjoyed this module because it taught me, well, one, it taught me a completely new programming language I'd never used before, which is Python, which incidentally is probably the most important programming language that you could use and learn now if you are planning to do anything sort of scientific and in the physics industry or field. But other than that, it was a really good way to teach me skills for how to tackle a problem, how to approach a problem, and how to go about finding a solution. Moving on to year 2, we still have a few introductory modules, but we start to specialise a little bit more and get into more complicated concepts. So in the first semester we had 4 modules, and in the second semester we had 4 modules, and over both semesters we had 1 double semester module. So in the first semester, the first module was called Physics of Fields and Flows, and this was a module about gravitational and electromagnetic fields and fluid dynamics. Now, I really wasn't too fond of this module, and a lot of people found this module really difficult, so it is one of those modules that covers topics like vector calculus, the divergence theorem, and stuff like Maxwell's laws. And although, you know, some people may find those intuitive, I just really didn't sort of grasp those topics as well as perhaps other people could. And so, yeah, I just didn't really enjoy that module, and I know a lot of other people struggled with it as well, and for a lot of people it was one of their least favourite modules. Next was an introductory module on quantum mechanics, which gave some introductions to the Schrödinger equation and to Heisenberg's uncertainty principle, and the Dirac notation, as well as a little bit on the hydrogen atom as a quantum mechanical system. Now, even though I was studying astrophysics and I was more interested in the large-scale universe stuff, this was perhaps one of my favourite modules throughout the whole degree, and I think it was just because of the way that I could learn something new for the first time and hadn't really had any experience with quantum mechanics before. And a big part of that had to do with the way that the module was taught. The lecturer for this module was really interactive, even though the module was taught through videos online, and even though the concepts are really difficult and really abstract, he taught them in a way which I found to be really intuitive and allowed me to really understand them. Next was a module called Structured Programming, which was kind of an add-on to the first year module that we had on programming, and this module kind of just taught us more of the complex techniques for analysing and visualising data in Python, and taught us more modules and more libraries that we could use in Python to analyze data. And this is perhaps one of the most useful modules I took, because for my research project in the third year I used a lot of the techniques and libraries from Python that we were taught in this module to analyze my data for my research. And the final module for first year was a module called The Stars and Their Planets, and this was a module, as you can guess, about stellar and planetary physics, more so focused on stars and stellar physics, but the planets came into it through stuff like exoplanet detection methods that we use, and then also a lot of stuff about the formation of stars and the death of stars through supernova, and depending on how big the stars are, how massive they are, we can sort of determine how they will die and when they will die. Now, I particularly enjoyed this module. I thought that the content was well taught, and it was generally an interesting module and something that was used then later on in third year modules. So moving on to the second semester, and we had 4 modules again. The first of these was a module called Thermal and Statistical Physics, which covered the basics of thermodynamics and statistical physics, and that was basically just a module on heat and what heat is and how heat transfers between objects depending on the scale that we're looking at. So when we're looking macroscopically at physical big things like this table or this book, we can think about heat in terms of thermodynamics and those sort of concepts within thermodynamics. But when we zoom into the atomic scale, we need to use the statistical physics concept, because then things become statistical probabilities rather than actual quantities. So it's a little bit abstract, but it actually made a good amount of sense when we was taught the concepts in an intuitive way. Then we had a module called Optics, which, as you can guess, was a module about optics, about light and lenses, and I really enjoyed this module, especially since I already had an interest in stuff like cameras and lenses, so I had a bit of an intuitive advantage, I guess you could call it, when it came to knowing stuff like apertures and f-stops and focal lengths. But this module was interesting not because of necessarily the content that we was taught, but more so because of the way we was taught it. So this was a really interactive module where we was sort of, in several cases, teaching ourselves and teaching others the content, which was skills that we learned which are really useful, especially going forward into other modules where it's important to sort of give presentations. So being able to practice skills like teaching other people stuff was really beneficial, and this module I found was a really just interesting module in general. Staying on theme with that sort of teaching other people stuff, we had another module similar to that called Synoptic Astrophysics, and this was a module not so much focused on teaching us concepts in astrophysics, but allowing us to practice our skills for solving problems in astrophysics. So we were split into groups, and we was given an unseen problem or challenge each week, which we had only a few hours to solve, and we had to work collaboratively in the group to come to that solution and then upload the solution by the end of the session. So the final module we had during this year was a module called An Introduction to Condensed Matter Physics. This was a module about sort of semiconductors and crystal structures and subatomic scale stuff. It was a really complicated module, and some of the maths was pretty difficult, but it was in general a really interesting module, especially since semiconductors are so important to modern life through all technology that we use. So, you know, this is becoming a more and more important module to be taught, and if you went down the physics route rather than the astrophysics route, you would have had another module on this in the third year, but this was my only module on condensed matter and semiconductor physics. So the final module for the year was a double semester module, so it ran from the start all the way to the end of the year rather than stopping at Christmas time, and this was called Observational Techniques in Astronomy. And this was a module about how we use telescopes in real life, and how we analyze and present data from telescopes in the best way possible. So what I really liked about this module is the fact that for the first half of the year we were sort of taught the skills that we would need to be able to analyze and visualize data that came from telescopes, and then from the second half onwards was our chance to actually perform real research and real experimentation through telescopes. So we had to write a telescope proposal to the LCO network, which then performed these observations over Christmas, and then when we came back we had the data from the telescopes, and we had to analyze the data, come up with hypotheses, and present the data through an actual report. So all in all, I really enjoyed year 2. I thought it taught a good balance between foundational basic stuff like thermodynamics and fields and flows, and a good balance of more abstract new concepts like quantum mechanics and semiconductors and the theories behind stellar evolution. So there was a good balance there, and sort of played well into the modules that we were taught in third year. And finally, we come to the third year. This is where we had our final year project report, which involved actually performing our own research. And also we was taught a lot more specialized modules for astrophysics and space science. So first up was a module called Atomic and Nuclear Physics. Now this was the hardest module that I took throughout the whole degree, and that's because the maths was super complicated and the concepts were super abstract. So there was no real middle ground of something where I could actually get a grasp of. I had to focus a lot on learning the maths and a lot on understanding these abstract concepts. So this course was sort of an addition to the introductory quantum mechanics course, but sort of skipped past all of the introductory stuff and focused straight away on the complex ideas. So as I said, this was a really difficult module, and even though it was really difficult, I did enjoy the process of trying to understand and grasp these concepts. Next was perhaps one of my favorite modules throughout the whole degree, which was cosmology. And this module focused on the history of the universe from the Big Bang to the present day, and how the universe evolved over that time. Cosmology is often voted as one of the best modules in the third year, and that's because the concepts are interesting, it's taught in a really intuitive way, and it also helped that the lectures were back in person during this year, so it was a lot more interactive. Next, we had a module called The Formation and Evolution of Stars. This was a module that pretty much followed on from the Stars and Their Planets module in year 2. Covered a lot of the same topics, but also explored more complicated theories for stellar formation and how they evolved through to their deaths, depending on how big they are. You know, as I said earlier, stars have different deaths depending on their masses. And so this module focused on that, and as well as that, it focused a little bit on stuff like neutron stars and a bit on black holes as well. So it kind of gave a full spectrum of the stellar life cycle, and obviously all the maths and the concepts that was involved at each significant stage throughout that life cycle. And the final first semester module that I took was a module called Electromagnetic Radiation Detection, and I really did not enjoy this module at all. I had the option between choosing this module and another one, and in hindsight I probably would have chosen a module like environmental physics, which from what I heard was a lot more interesting than this module. Now, this module focused on the electromagnetic spectrum and the methods that we use to detect sources at each part of the electromagnetic spectrum. And although that's an interesting concept in and of itself, and learning about those was pretty interesting, especially the stuff on the space telescopes. There was a lot of a focus on stuff like noise and gain and sort of antennas, which I really didn't enjoy, and the concepts that came around those sort of topics weren't really intuitive to me at all. And then finally, in the second semester, we had 3 modules. The first of these was called Galaxies and Galaxy Evolution, and as you can guess, this was a module about the different types of galaxies, how they form, and then eventually how they evolve. And this was a really interesting module. This is sort of cutting edge science. This is what people are looking at with the new James Webb Space Telescope. And so I found this module really interesting. We also got a chance at modeling a galaxy through Python, which was an interesting assignment. And although it was pretty difficult, it taught a lot about sort of how we model stuff in physics. Next was a module called Particle Physics and Special Relativity, which, as you can guess, was a module about particle physics and an introduction to special relativity and how the two topics sort of interact. The particle physics stuff I didn't find as interesting and as intuitive. So it was first introduced to the sort of standard model, which most people are at sort of A-level physics, maybe even before that. But we quickly moved on to some more complicated stuff, like how subatomic particles interact through quantum electrodynamics and quantum chromodynamics. Now, those were topics that I hadn't really experienced before, I hadn't really had a chance to try to grasp or understand, and I found them pretty non-intuitive. So in general, I found the particle physics stuff to be pretty difficult. And the final single semester module was High Energy Astrophysics, which was my favourite module throughout the whole degree. And I think that this is the module that most people would imagine when they think of astrophysics. Now, this module focused on stuff like neutron stars and black holes and magnetars and quasars and these massive gamma ray bursts that come from the active galactic nuclei of galaxies. So those were all of the taught modules that we had throughout the whole degree. Now, as I said, we also had a third-year research project, and that was a module where we had to perform our own research by coming up with our own ideas and trying to link our ideas to other sort of scientific publications and papers. And so the first part of that, throughout maybe the first 4 or 5 weeks of the first semester, we was focusing on developing these ideas, our understanding of certain concepts, and reading science papers in the field. So as I said, I did mine in star clusters. Then we sort of started developing the background knowledge for it, and then from Christmas onwards we sort of focused on trying to use real data to prove these theories right and to prove these ideas right, and then finally writing the report then. Now, I won't go into too much depth about the process of making these science reports and a third-year science paper, because I want to make a completely separate video on that. So that's it. That's my complete astrophysics degree summed up in one video. I've gone over all the modules that I took and my opinions on each of them. So if you are considering studying astrophysics or any of those modules, you should hopefully be able to make a little bit more of an informed decision about it. If you have enjoyed this video, I'd really appreciate you giving the video a like. And if you want to stick around for more videos in the future like this, make sure to subscribe to the channel. With that being said, I want to say a massive thank you for watching, and I'll see you in the next one. Bye bye.